Hi, this is Dr. Heike Bielek from Into Infinity, and in this episode we're going to talk about numbers, in particular the concept of square numbers. Who doesn't like money? Do you ever had these coins in your hand and think, oh, this is 1, 2, 3, and so on? So normally we count life within, counting things, and we go, this is a 1, this is a 2, and this is the 3. And that you can place around, and that looks like, well, guess what? A triangle, right? And you could do the same, if we had 4 with a square. And there's this thing called the squaring of numbers. We miss out when we look at a triangle. And that only becomes clear once you start to understand how to look at the shapes, not through counting them and adding things, but how to look at the things when you divide them. Because when we looked at fractal geometry, we were actually looking at how shapes behave when you divide them, not how you add them. So when we take a triangle then, and we said we're going to divide it into half, or we can take a square and we divide it into half, well, that creates 4 squares, and that normally we would say, oh, that is 2 squared, because we take the edge, that's 2, and 2 makes 4. So 2 squared equals 4. But when we look at the triangle and we divide it into half, well, we have the same pattern, because we have 1, 2, 3, 4 triangles, and you could say the side is also divided into 2, so that's also 2 squared, and it creates 4 units, just like the square. Normally we wouldn't associate triangles with the notion of squaring. Whenever we talk about a square, well, there's a reason why it's called a square, right? You think about squares. We often don't see that actually by looking at the shape itself via division, that it can create the very same concept. But we have been missing out on that because it's the way our consciousness works, because we're looking at the way the numbers are counted. So we start with the 1, with the 2, and with the 3, and that's like, oh, that's a triangular number. But it doesn't create 4, it creates 3. What's missing here? Well, what's really missing here is the space in the middle, because we just don't see the space in the middle because we add the numbers and we don't divide them. See, this space in the middle is being missed in the concept of triangular numbers, which are actually square numbers. So by looking at the concept of squaring, we really find out that the triangle and the square behave really in exactly the same way. And whenever we see a squaring in an equation, it doesn't necessarily mean it's just a square. It could also refer to a triangle. So when we continue the pattern of dividing a square or a triangle, and just follow up on the square number series, which is 1 squared, 2 squared, 3 squared, and 4 squared, we can see how the same pattern applies to the triangle. So 1 is 1, right? If we have 2 squared, which I explained already, you got the 4 squares or the 4 triangles. The only difference is that the triangle behaves different because there is a space in the middle. Now we know that relates to the chaos game and the Sierpinski fractal. When we go to the 3 squared, well, that's 9. Each edge has 3 squares, and then times 3 squares, 9 squares. But the same applies also for the triangle. So here again we get 3 triangles on each edge, and that creates 9 triangles in total, whereby these ones upside down ones are 3. So there is a little bit of a difference, because here we got 4 and here we got 3. But in totality, they have the same number of components. And then here, 4 squared, we can see how this mechanism repeats, adds up to 16. And for the triangle, it's the same, 1, 2, 3, 4, 5, 6, compared to 1, 2, 3, 4, 5, 6, 7, 8. And the square and the triangle are really fundamental shapes in geometry, because looking at these patterns, we can see how this pattern can repeat into infinity, fill a whole space. The second dimension really goes back down to just these 2 components known as the square and triangle, the 2 types of 2D.